Chapter 10.3 is section 3 of chapter 10, and the problem number is 1029. And we're comparing the populations for two independent proportions for two populations, and it's going to be a z-test. Online survey asked 1,000 adults, what do you buy for your mobile device? This problem is found on page 346, again, number 1029. The results indicated 61% of the females and 39% of the males answered closed. The sample sizes for males and females were not provided. If we assume that the sample sizes were both 500 and 195 males and 305 out of the 500 females reported buying clothing from the mobile device. Is there evidence of a difference between males and females in the proportion who buy clothing from their device at the 0.01 level? What is the p-value? And then we want to do a confidence interval after that. Okay, so step 1, null and alternative. The proportion of males and females who use their mobile device to buy clothes is the same, and the alternative is not the same. So again, we could use pi 1 and pi 2, or capital P1, P2. Second step, we write down the information. N for males is 500, and for females is 500, and alpha equals 0.01 because that's what it told me in the problem. Step 3, what test should I use? Well, because I'm talking about percentages, all I've got is N, sample size for each group, and the number of people who said they buy clothing on their mobile device. So it's not a mean and it's not a standard deviation, so it's got to be a proportion problem. We have two populations, two different samples, so we want to use a z-test. To make sure that we can use this test, we need to know that we have a normal distribution. Our formula or test for normality says n times p and n times 1 minus p. Both of those products should be at least 5. Since we have a large sample of 500 for males and females, and the proportions are pretty close to 0.5 at 0.61, 0.39, we're not likely to have a problem with this formula. So if we multiply 0.61 times 500, 0.39 times 500, we get 305 and 195. So it's not even close to being 5. So that says I can use a z proportion test. Step 4. I've got my pH stat up, which says z-test for difference in two proportions. So the hypothesized difference always is 0, remember. The level of significance is 0.01. So what we've done here is we've included the numbers that they gave us in the problem. 195 for males out of 500, 305 out of 500 for females. So those are the proportions, 39 and 61. And you can see then the critical value for a two-tailed test, because it asked me if there was a difference. So if we go back here, difference between the two proportions, so that's how I know it's two-tailed. My lower and upper limits are minus 2.5758, positive and negative, which it gives me on the printout. So there's my critical value number, plus or minus 2.5758. Step 5. I use this formula. Remember, I think the population proportions are the same, so that part drops out, and I just calculate the numbers, which the computer has done for me. So I can go to my z-test statistic, minus 6.957 is the number, almost 7 standard deviations below the mean, so it's not a hard decision to make in step 6. We go here, reject the null. Based on a significance level of 0.01, we have sufficient evidence to conclude there is a significant difference between the proportions of males and females who buy clothing from their mobile device. I have 99% confidence that a change in policy is needed because P1 is not equal to P2. The p-value, if we look at the bottom of my pH stat printout here for the z-test for two proportions, I get 0.00000. So it is basically equal to 0. That value is well below 0.01, so that's why I'm rejecting the null, and that's why I have nearly 100% confidence that I can, in fact, reject the null. Okay, part C, let's go back to the problem again. it said, construct and interpret a 95% confidence interval estimate for the difference between proportions of males and females who said they buy clothing from their mobile device. All right, so this is what the formula we use. P1 minus P2 plus or minus Z alpha divided by 2, because remember it's a proportion problem, so it's got to be a Z value. And we have the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. And I take the square root of that whole thing. All right, so again, if I use PHStat, I put in my confidence level, 99%, my Z value, 2.5758, and therefore I come up with these limits. Minus 0.2995 minus 0.1405, which tells me that I have, here's the way I write my answer, pi 1 minus pi 2 is between, and again I could use P1 and P2 there, which might be better just to keep me consistent. All right, minus 0.2925, that's a difference of nearly 30%, and this is a difference of 14%. The key thing to notice is both of these numbers, upper and lower limit, are both negative. And because they're negative, that means when I take group 1 minus group 2, I come up with a negative number. That tells me that proportion 2, or the female proportion that buy clothing, is greater than the male proportion by between 14% and 30%. And this is the way I wrote it down here. We're 99% confident the difference between the proportions of males and females who said they buy clothing from their mobile device is between negative 0.2995 and negative 0.1405. Therefore, the proportion of males who buy clothing is between 14 and 30% less than females, as both limits are negative. That's the key thing. If the values are both the same sign, that tells me there is a difference. If one is negative and one is positive, I would have zero confidence that there is any difference, because the difference might be equal to 0. Okay? And then the final step of this problem, which is part D, if we go back, says, what are your answers to A through C if 270 males said they buy clothing from their mobile device? So we're going to use the same process. All we're going to do differently is we're going to plug into our formula the different values, and we'll continue to use PHStat. So notice I've got 0.01, but I've got 270 instead of 310 that it was before, I think. Let me see what it was. 195 is what it was before. Now it's 270, and this one is still 305, which is the same as what it was before. All right, so now what I do is I calculate things again and go through my 6 steps. Again, the proportions are equal, the proportions are not equal, who choose to buy clothing from their mobile device, and I still have sample sizes of 500 both times. Here's my critical value, which is going to be 2.5758 for the upper and lower values, because it's still 0.01, and my Z-stat calculated value for step 6 is 2.2389 now. So that's less than or between the two critical values, and therefore I will fail to reject, which means if I need to use an alpha level of 0.01, I do not have sufficient evidence to conclude there is any difference in the proportions of males and females that buy their clothing from the mobile device. The difference that exists, we would presume, is probably due to sampling error. Okay, and here's the confidence interval. Again, still 99%. The Z value is still the same. And here are the upper and lower limits that I get for the difference between the proportion of males and females that buy their clothing from the mobile device. And you'll notice we've got a negative 15 and a positive 0.01. So that says there is no difference, because one's negative and one's positive, and we can now say it's somewhere between 15% and 1%, but because one is negative and one is positive, there is not a significant difference between males and females in the proportion who buy clothing. The way we know that, reason we know that, is because the interval crosses zero. One's negative, one's positive. So there's no difference in the proportions. This negative 15% would mean what? It would mean that the females are still buying more clothing through their mobile device than males. But the plus 0.01 means males may be buying even 1% more. So the key question is, does the interval cross zero? If the answer is yes, then that means no significant difference. If the answer is no, like it was over here, they're both negative or both positive, that says there is a significant difference.